All right, the bad news, we are running late. The good news, because I only had 10 minutes last year, that was all I prepared this year until I realized this morning that I actually have half an hour. But never mind, we'll try to end it soon as possible. This is basically an introduction to the Supercomputer Center in Singapore, who we are, what we do, what are our future plans. Essentially, the National Supercomputing Center of Singapore, like I said, is the national center. We provide HPC resources not just to the academia, but to the industry as well. Okay, the 4 universities you see below are the founding members. This group of people went to the government one fine day and said, give us a pool of money, we need to build a supercomputer. It took them a few years, but long story short, we're here today. And what are the things we do? Okay, this is a slide done by my PR folks. The gist of it is, we do not just serve the academia, we serve everybody else in the country who need supercomputing facilities. And I have to dispel a myth that has been perpetuating. We are not the closest supercomputer center from Perth. As the crow flies, you can read the distances in kilometers. And if you decide to take a flight instead, the numbers in blue, that is how long you will have to spend in the air. But having said that, we are friendly with everyone. We love to have friends, the more the merrier. Those of you who have not visited us, this is where we are. This funny futuristic looking building somewhere in the south of Singapore, right up there on the 17th floor. That area marked out red is our data center. And again, I have to answer this many times. Whoever decided to build a data center on the 17th floor, number one, it was a decision made long before our time and at a pay grade way above mine. In the past, we did not complain because the view from up there was fantastic. Okay, but today we are facing a minor problem. We have 1 megawatt to the data center, and we need quite a bit more. And there's no way we can bring another megawatt or 2 up. So the story is, in all likelihood, we have to move from this place. So if you haven't been to this place, this is your time to come visit us. Possibly the highest operational data center in the world measured from the ground. We will soon lose that title, not that I mind. Okay, a quick overview of our machine. The purchase order was issued in the year 2015. 1288 Haswell nodes and so on and so forth, with a LinPack benchmark of just over 1 petaflop. When it first appeared on the top 500 list, it was number 93. As of the June 2019 list, we are no more on that list. And we heard about cooling technologies this morning. We run our machines, not only do we cool our machines with direct water cooling, we actually run them hot. We have a huge dry cooler, something like that looks like a giant car radiator to cool the machines. So under normal steady state operations, so-called cold water enters the machine at about 30 to 35 degrees C, depending on the time of the day and the weather, whether the sun is shining or whether it's raining. The water temperature is about 30 to 35, and water exits the system at 40 to 50 degrees, again, depending on the amount of workload being done to the machines. And after 4 years of operations, we have not noticed any significantly higher rate of repairs to the equipment. And by not running our aircon at full capacity, we actually save a fair bit in our cooling costs. Today, we are hovering just below the 1.3 figure in terms of PUE. Some key figures at a glance. As of today, about 8 petabytes of storage is being constantly used. We have supported about 500 research projects, both past and present. Number of users who have come through our systems, about 5,000 as of today. And we are constantly seeing a utilization load of at least 90%, and more than 400 million CPU hours have been consumed from about 32,000 cores. Okay, this was something which we could bring forward thanks to very generous collaborators, partners, and supporters. We have international R&D links to various countries, to Japan, US, okay, it's not clear here, but we have a link to Hong Kong too, and of course to Perth. I was told that the 100G link to Perth has just been commissioned. Thanks largely also to the folks in ARNet. And we have a link to Europe via London, Brexit notwithstanding. Okay, what we have been assured is Brexit or no, the link remains. So we're safe. So the take-home message is, if you have a collaborator in Singapore, we are well linked to serve you. Okay, let's look at a few projects that have gone through our machines. Okay, back to the cooling story again. We heard about direct water cooling this morning. What about servers that are not designed for direct to chip cooling? And perhaps they are not too amenable to Johnson's baby oil. There's this company in Singapore that developed an alternative to the rear door heat exchanger, and we didn't quite realize that they were designing their cooling system on our supercomputers because it was hidden under the guise of one of those black industry projects. But they are ready to show their wares now. In fact, they showed it at our conference in March this year in Singapore. So according to the people who worked on it, they seem to get a higher efficiency than your standard rear door heat exchangers. So if you're not, so a bit of shameless plug here, if your servers are not cooled by direct chip cooling, and if you cannot soak them in an oil bath, this is an alternative to consider in addition to the standard rear door heat exchangers. So this is one project. Okay, climate modeling here. The various agencies in Singapore are doing all sorts of planning scenario. What if the temperature in Singapore goes up by 2 degrees over the next 10 years, over the next 50 years? What if you're building a new town? Now this tiny red dot here, I can't see. Okay, but that tiny little red dot here is a new town that's being developed in Singapore. And as they develop the town, the planners are considering the shape, the orientation of the buildings, how will it affect wind flow, how will it affect sunlight, heating, cooling. In essence, the livability of that area. So they're using a supercomputer to do this kind of planning. Okay, another project that we consider to be a poster child. Okay, Okay, Keppel Offshore and Marine, this is one of the biggest oil rig builders in the world. They actually use our machine to design oil rigs and also for forensics when they do ship repair. So they've been happily using it for quite a few years. Okay, this is a rather interesting project. It started even before NSCC was officially founded. What they do is that they look at the genome profile of 100,000 individuals in Asia, particularly Northern Asia, South Asia, and East Asian. And they profile all this genome with the intention of using it for precision medicine, cures that are targeted towards the Asian genome. And with our machine, they have managed to reduce the computational time of this 4-year project from what was projected to only 1% of this 4-year project. So now they are happily doing the downstream experiments. All in all, they've consumed, okay, I say 1 petabyte, but it's closer to 1.5, excluding scratch disk. And the final project that I want to talk about is something very interesting. Not too high an impact factor scientifically, but this was research done a few years ago by a group of high school students, or to be precise, the science club of a high school in Singapore. They were doing this strictly out of interest. They were playing around with spintronic materials, and what happens if you throw some graphene into it, what will happen to the magnetic properties of these materials. Okay, not too high an impact factor, but they have presented at a few conferences, and they have done a few posters. Okay, so that has been the last 4 years. What's next? We have been a service provider and a resource provider for the last 4 years. So the next few years, we need to plan ahead to develop HPC expertise in the country and to help the industry cultivate new capabilities. So basically, we do have people going down to the industry and say, can you do more than just what you're doing with your workstation? Can you do more complex models? Can you do bigger models? And we try to identify projects that are of strategic, scientific, or industrial importance to the country and support these projects, whether in terms of higher priority for resources or in terms of expertise. All in all, we need to foster the HPC ecosystem in Singapore, and we are always looking for international collaborators. If you have any projects which you think we may be of help, please let us know. So moving forward, that has been the past 4 years. In March this year, some of you were present too. This gentleman here, whom you see in the foreground, he's slated to be our next Prime Minister. He announced that the government has set aside $200 million to upgrade Singapore's supercomputing infrastructure. Let me clarify, not all $200 million go to buying a supercomputer. There are lots of things which it has to pay for. So we call the NSCC 2.0 and a few conceptual considerations. Number one, we realize that one size does not fit, or one machine, one single architecture will not serve everybody. So we are looking at a multi-tier system where we have different machines of different sizes to serve different national and institutional needs. The whole idea is to support Singapore's participation in international scientific endeavors. For example, the Genome 100K Consortium, which I just mentioned, this is the kind of project we will support. And we have been told to build infrastructure ahead of time. Not too far ahead of time, but enough so that we will not be caught when there's a sudden demand for resources. And all these machines are useless without the manpower to run it, without the manpower to use this machine. So we need to develop manpower capability as well. The whole idea being that we will enable our stakeholders to undergo digital transformation, be it IoT, big data, quantum computing, and so on and so forth. So expanding on what we already have, we will have a common identity management, integrated logins, and parallel file system. We will write on the national research network infrastructure to connect all these things up. Right sizing, basically, we will buy machines as needed, not too big, not too small. And these are our high-level plans, heterogeneous systems, something for the biologists, something for the CFD folks, something for the for the MD folks. Not a single system, not trying to fit a square peg into a round hole, but we will build a heterogeneous environment for everyone. And with that, we will have a common pool of storage also, which will be centrally managed. And we will not spend all the money at one go. We will phase in the acquisition. And the machines will be geographically distributed. And yes, the word there is data centers, not a single data center. Okay, for various reasons, which I'm unable to say now. But otherwise, okay, we have planned for these data centers to be ultra green and to run warm or hot in a humid tropical environment. We have run our machines hot for 4 years, and we are confident that existing technologies will run without problems, with no problem, in this kind of elevated temperatures of 40 degrees or more. And we intend to build a data center with intelligent feedback to control the temperature, to control the environment, energy aware, thermal aware scheduling, and not just based on the next available call. Some of you have actually attended a tender briefing a few months ago at the National University of Singapore. Yes, that is one of our data centers. And riding on the national network infrastructure, SLICs, or Lightwave Internet Exchange 2.0, they are upgrading also. So that will constitute the baseline R&E network infrastructure, which covers all the major research hubs in Singapore. Okay, this is how the network currently looks like. Long-range InfiniBand to our key stakeholders, to our key partners. But in future, we intend to extend the network not just to the existing partners, but to other universities, other industrial research hubs in Singapore that may need a supercomputer. And all these people have already indicated that they do need a supercomputer. Okay, I think I spent less than 10 minutes. And with that, let me end with a truly shameless plug to please attend our conference in Singapore next year. It will be in February 24th to 27th. The exact venue to be determined, but please come. Okay, with that, if there are no questions, thank you for your time.